Hi, this is Mr. Chu and I welcome you to my study room. Today we are taking essay question 9 of the 2024 WASSCE core mathematics paper written by Ghana, and it has a diagram that is not drawn to scale and erased. In the diagram, KC is an arc of a circle center T. BC is a tangent to the circle as C, and TB is a straight line. The length TC equals h root 3 centimeters and angle KTC equals 60 degrees. Calculate A, the length of KB. B, correct to three significant figures the area of the shaded portion. Take pi equals 22/7. Let's start the A. And we'll start right by saying that if BC, which is here, is a tangent to the circle, then it means that the measure of angle TCB is 90 degrees right here. This is TCB is 90 degrees because one of the circle theorems says that the angle between the tangent and any segment through the center of the circle is 90 degrees. So if BC is a tangent and T is the center of the circle, then the angle between the two of them will be 90 degrees. So that is the first thing we need to get. Let me just write that quickly. Alright, now that we established that fact that this is a right triangle, we can also add another information that this is 30 degrees, and that makes this triangle a 30, 60, 90 degree special triangle. And if you've been watching this channel for some time now, then you should remember that we've established that in so many videos that if we have a right triangle this way, and the side that is directly opposite the 30 degrees angle has the length x units, then the hypotenuse will have the length 2x units, and then the side that is directly opposite the 60 degree angle will have the length x root 3 units. Right. So now that we know that, we can apply that to this one, that this side, which is opposite the 30 degrees, has the length h root 3 centimeters. Okay. So if that is our x, then our hypotenuse will be 2 times that, which will give us TC to be equal to, let me write that here, 2 times 8 root 3, which will give us 16 root 3 centimeters. And then now we'll have the other side, BC, which will be, let me use a different color, 8 root 3 times root 3, which will now give us 8 times 3, which is 24 centimeters. And that is for those who remember the special triangle properties to use. But if not, then that means you can also use the SOHCAHTOA to find your missing sides. For example, if I want to find the length TB, which is this, the same as the hypotenuse of this triangle, this side here is adjacent the 60 degrees, and like I said, this is the hypotenuse, right? So I'm going to use cos in terms of SOHCAHTOA. So I am using cos because cos has adjacent and hypotenuse. So taking cos of the 60 degrees, I'm going to have cos 60 degrees equals adjacent is 8 root 3 over hypotenuse is TB, which we are now solving for. Rearranging them, I'm going to have the length TB to be equal to 8 root 3 over cos 60 degrees. And the length TB will be equal to, let's find that on a calculator and bring my fraction first. So 8 root 3 over cos 60, and that gives us 16 root 3. So let me write that. And let me say that this is very consistent with what we got here for TB when we use the special right triangle properties. And then we also know that, so let me put also, the length TC is equal to TK because each of them is the radius of the circle. So there will be 8√3. So this is the radius of the circle and this is the radius of the circle. So they are equal. So this is also 8√3. And that means that the length TB will be equal to the length TK plus KB. And now we know TB to be 16√3 and TK to be 8√3. And now the KB, which we are solving for, will now be 16√3 minus 8√3. And that's just by using basic idea of surds or radicals. That will be 8√3 centimeters. Or we can still verify that with our calculator. 16√3. Remember to bring the cursor out of the square roots. Then minus 8√3. And that equals 8√3. Alright. Therefore, we are now done with A. The length KB is 8√3. You use any approach that works for you. Now let's go to the B. B asks us to find the area of the shaded portion correct with 3 significant figures. So we'll first start by finding the area of the bigger triangle, which is triangle TCB. And then we find the area of the sector TCK, and we subtract that from the area of the triangle TCB. So first of all, since triangle TCB is a right triangle, we can use the formula half base times height because the TC and BC are perpendicular to each other since there's 90 degrees between them. So one of those sides can be the base and then the other the height. Remember, we got 24 centimeters when we work this one. So you are at liberty to use that, or we can also use half AB sine theta. So let me just write that quickly. Alright, so stating this, I just could have been specific, but then like I said, anyone can decide to use the side BC as the base and the TC as the height, or TC as the base and then BC as the height. So that's why I just still maintain the base times height so that you choose whichever works for you. And then also, if it were not a right triangle, we still could have used a half AB sine theta, where the AB are two sides and an included angle, meaning that we can use the side TC and TB, and then we use the 60 degrees as our theta, or we use TC and BC and we use the angle 90 degrees as our theta, or we use BC and BT and we use the angle 30 degrees, since we know that this is 30 degrees as our theta. So again, that is our own choice. That is why I didn't use a specific size to write a formula, but rather write them in a general form. So using this second approach, assuming I didn't know all these size, or assuming I didn't know this height to be 24 and I don't want to waste my time on that, then I'm going to have 1/2 GC, like I said, I'm being specific now, times TB, then times sine 60. I'm now being specific, so I'm using TC, TB, since I know TB already according to the first A that we solved. So that is going to give me 1/2 times TC is 8√3, then times TB is 16√3, then times sine 60. And this will be equal to, let's work that on the calculator quickly. So you're going to have 1/2 times 8√3. Remember to bring the cursor out, times 16√3, and then times sine 60. which is the angle between the two sides you've chosen, 60, then equal to, so that gives us 96 root 3. And let's just change it to decimal as well to see what we get. So 166.2769 approximately. So I'll write both of them, and when we are doing the subtraction, we'll decide on which one we should choose. So that gives me 96 root 3, which is approximately 166.2769 cm squared. Remember, it's area. And we are not done yet. This is just the area of triangle TCB. So don't forget that. That's the bigger triangle. Now let's go ahead and find the area of the sector TCK, so that we can take that out of the area of the triangle to get a shaded region. So that's what we're going to find now. And we are going to use the formula for the area of a sector. So let me write that quickly. Area of sector TCK equals, we are using formula for the area of a sector, which is theta divided by 360 times the area of a circle, which is pi r squared. Now coming to this particular question, the central angle there is 60 degrees over 360. I can just take off the degree for now, times pi. The question gave us to use 22/7, so we use that 22/7 times the radius is 8 root 3 squared. And let's just put that back into our calculator. 60 over 360 times 22/7, then times 8 root 3. Remember to bring the cursor out, and then squared. And then we hit the equal to sign. And that gives us 704/7. And again, you would like just to compare the decimals. So that will give us 100.5714. So let's go ahead and write that. This will be equal to 704/7, which is approximately 100.5714 centimeters squared. So now the area of the shaded region is going to be the area of the whole triangle, as I said earlier, minus the area of the sector. So that is what we are going to do. Let me just write that quickly. And that will be equal to 96 root 3 minus 704/7. And I mean, you can use the decimals as well. That's why I wrote both of them, so that you can choose the one that you want to use. And that is going to give us, let's work that on the calculator. 96 root 3 minus 704/7, then equals, so that gives us approximately 65.7054. So let me change my equal to sign to approximately sign. Approximately 65.7054. This is just to 4 decimal places. But now I come back to this part of the question, which says that we should round that correct to 3 significant figures. So coming back, I'm going to have approximately 65.7 square centimeters. And this is correct to 3 significant figures. And that is the area of the shaded portion. And that is where we end the study for today. And I hope this lesson has been of help to you. If yes, then don't forget to subscribe to this channel for more videos like this. Till we meet again in my study room. Bye bye.